Hello there, Mr. Sutton here, bringing you the Algebra 2 Chapter 10 Quiz 1 Review Solutions on Trigonometric Ratios and Functions, Part 1, dealing specifically with the unit circle. For this problem, they've given us a right triangle with all three sides given, and they want us to figure out all the different 6 trigonometric functions, the values of those, for this theta that they're pointing out in the diagram here. All right, so let's start with sine. Sine is going to be opposite over hypotenuse. So in this case, sine of theta is going to be the opposite side 8 over hypotenuse 13. Next, we've got cosine, which is adjacent over hypotenuse. This is the adjacent side right here. It's the leg of the angle that's not the hypotenuse. So we're going to have radical 105 over 13. And then for tangent, we've got opposite over adjacent. So that's going to be 8 over radical 105. And we're going to multiply the top and bottom by the square root of 105 just to get that radical out of the denominator. So that's 8 radical 105 over 105, which I can't really reduce anymore. Now I'm going to do the reciprocal functions. Each of these is just the original flipped upside down. So cosecant is the reciprocal of sine. It's hypotenuse over opposite. So just flip this to get 13 over 8. Secant is the reciprocal of cosine, so hypotenuse over adjacent, which in this case means 13 over the square root of 105. We do have to simplify that radical though, so this will be 13 root 105 over 105. And then lastly, we've got cotangent, which is the reciprocal of tangent, so adjacent over opposite, which in this case means we have radical 105 over 8. For this problem, we're trying to convert from radians to degrees. To do that, we're going to multiply by 180 degrees over pi radians. And now we're going to cancel a few things out. The pi's will cancel, they usually do. And then we can cross-cancel 108 and 4. That gives us, let's see here, 45. And this is just a 1 down here. So multiplying across, 7 times 45, that's going to be 315 over 1, so just 315 degrees. For this problem, we're trying to convert 300 degrees to radians. So for that, we're going to multiply by pi over 180 degrees. That'll cancel out our degrees. And then I can reduce 300 and 180. Those are both reducible by 60. So this is then going to be a 5 and a 3. So 5 pi over 3. On this problem, they're giving us the point negative 2 comma 4 as the point on a terminal side of an angle in standard position. They want us to evaluate the 6 trig functions of theta. So in order to do that, we've already got an x and a y. So we've got an x value of negative 2, y value of 4. We also need to find the radius in order to get all 6 trig functions, because right now we have enough for tangent and cotangent, but we need radius for the other 4. So to get that, we're going to use our Pythagorean theorem. So I need the square root of x squared plus y squared, so of negative 2 squared plus 4 squared. That's 4 plus 16, which is 20. Square root of 20, we can simplify this a little bit. We might as well just do that now, because otherwise we'll have to do it every single time we deal with this thing. So I can split this up into square root of 4 and square root of 5. Square root of 4 is 2, so 2 radical 5 is what we can simplify this to. At this point, now that I've got x, y, and r, I'm going to write out all 6 functions, starting with sine. Sine is y over r. So in this case, we've got 4 over 2 radical 5. And it looks like I can simplify this a little bit. Let me first get the radical out of the denominator. So I'm going to multiply by root 5 over root 5. That gives me 4 radical 5 over 2 times just plain old 5, so 10. So we have 4 root 5 over 10. And then I can simplify the 4 and the 10, reduce those to a 2 and a 5. So 2 radical 5 over 5 when the dust settles. Next up, let's do cosine. That's x over r. So in this case, that's negative 2 over 2 radical 5. And we're going to do that dance again. So initially, this will be negative 2 radical 5 over 10. And then I can reduce the 2 and the 10 to be negative radical 5 over 5, which is kind of interesting looking. All right, let's do tangent next. That's y over x. So that's 4 over negative 2, which I can reduce to negative 2. And now I'm going to do the three reciprocal functions by just flipping the end results of these first three. So cosecant was r over y. So in this case, that's going to be 2 radical 5 over 4. And I can reduce that to be just radical 5 over 2. Next up, let me do secant, which is r over x. So that's going to be negative 2 radical 5 over 2, which I can reduce to just negative radical 5. And then finally, we're going to do cotan, which is x over y, the reciprocal of tangent. And so that's going to be the reciprocal of negative 2, which is negative 1/2. For this problem, they want us to find cosine and sine of theta for the quadrantal angles. That's 0, 90, 180, and 270. And they gave us a chart to fill out, actually. So here's the chart that they gave us. So the most efficient way to do this is just to go angle by angle. Cosine is the x value, sine is the y value of the angle. So let's just do it that way. So at 0, we've got the point, at 0 degrees, we've got the point 1, 0. So that's a cosine of 1 for the x value and a sine of 0 for the y value. Up here at 90, we've got the point 0, 1. So that's going to be 0 for the cosine and 1 for the sine. At 180, we've got negative 1, 0. So cosine is negative 1, sine is 0. And down here at 270, we've got 0, negative 1. So 0 for cosine and negative 1 for sine. For the next few problems, they want us to find exact values of expressions without using a calculator. So here's cosine of 150. Since this angle is already between 0 and 360, I don't have to add or subtract 360 at all. I can just go straight to graphing this and seeing where we are. So at 150, we're somewhere in here between 90 and 180, probably right about here. So we are in quadrant 2. And in quadrant 2, cosine, which is the x value of the angle, is going to be negative because we're to the left of the y-axis. So when I rewrite this with a reference angle, which is what I'm going to have to do to evaluate this, I'm going to make this a negative cosine of something. So what is my reference angle? Well, the reference angle, remember, is just how far you are from the closest x-axis angle. So we're closest to 180. To get all the way to 180 minus 150 would be 30 degrees. So 30 is our reference angle, this angle between the x-axis and the terminal ray. So I'm going to rewrite this then as negative cosine of 30 degrees. And 30 is one of my special angles. The cosine of 30 in my chart that I have is radical 3 over 2. So this then is going to be negative radical 3 over 2. For this problem, I want the exact value of cotan of 3 pi over 4. To make my life a little easier, I'm going to convert this to degrees so that I have a better sense of where it is. So 180 divided by 4 is 45. 3 times 45 is 135, so that's 135 degrees. And then just calling up my unit circle here, 135 is somewhere here in quadrant 2 between 90 and 180. Since we're in quadrant 2, what is cotan going to be positive or negative over here? Well, cotan, remember, is the reciprocal of tangent, so it behaves like tangent in terms of whether it's positive or negative. Tangent is the slope of the angle. This is a negative slope right here. So that's one way of telling that cotan is going to be negative in quadrant 2. Alternatively, you might remember that cotan is x over y. Over here in quadrant 2, we have a negative x and a positive y. Opposite signs in division means you're going to end up with a negative overall result. So in any case, let's get our reference angle. We are closest to the 180 line here. 180 minus 135 gives us 45. So I can rewrite all this as negative cotan of 45 degrees. Okay, let me express this now in terms of sine and cosine. There's another way to do this that's a little quicker that I'll go over in a minute, but this is kind of the original recipe here. So I can rewrite this as negative cosine of 45 over sine of 45. Cosine and sine of 45 are both radical 2 over 2. Since I'm essentially dividing something by itself, this comes out to negative 1. Now, another way you could have done this, you might know that the tangent of 45 is 1, and this is really just negative 1 over tan of 45, so that's another way of arriving at negative 1. To get started on this problem, let's go ahead and convert this to degrees just to make the visualizing a little easier. 180 divided by 4 is 45. 5 times 45 is 225. And let me get a reference angle for this thing now. But let me also graph this so I can see where I am at. 225 is right about here between 180 and 270. It's actually halfway between that in terms of angles. So if I'm in quadrant 3, just thinking about the sign of my cosecant here, cosecant is based off of sine, which is the y value of the angle. Down here, y values are negative. So this is going to be negative in quadrant 3. And the reference angle, we're closest to 180, so I can just do 225 minus 180 to find this angle distance to the x-axis. So that ends up being 45 degrees. So we end up then with negative cosecant of 45 degrees. Now I can express this in terms of sine to go a little bit further on this. So this is really negative 1 over sine of 45. Sine of 45 is root 2 over 2. If I flip that, I've got negative 2 over radical 2. But now I have to multiply by radical 2 over itself to get that radical out of the denominator. So this is negative 2 times radical 2 all over 2, which if I cancel out those 2's just ends up being negative radical 2. For this problem, we're trying to do secant of 330. That's already in degrees and in standard form. So let me just graph it out and see where we're at. So we've got 330 here in quadrant 4, somewhere between 270 and 360. Since we're in quadrant 4, and since secant is based off of cosine, and cosine is x values, that means we're going to have a positive cosine, positive x values, and a positive secant over here in quadrant 4. So positive there, that's nice. That means when I change it to a reference angle, I don't have to make this negative. So the reference angle, we are closest to the 360 line. 360 minus 330 is giving us 30. So 30 degrees there. We can rewrite this as secant of 30 then. And now let's express this in terms of cosine. This is really 1 over cosine of 30. Cosine of 30 is radical 3 over 2. And if I flip that, I've got 2 over radical 3. And then if I multiply by radical 3 over itself, I have 2 radical 3 over 3 for my final answer. For this problem, which is on the honors version of the review guide, we're trying to find the arc length and area of a sector that has a radius of 16 feet and a central angle of 90 degrees. Now this one we can do with just a couple of formulas. For arc length, you might remember the formula is going to be r times the theta, r times the angle. So if we have a radius of 16 and an angle of 90 degrees, we're doing 16 times 90 in radians. You have to convert it to radians. So 16 times pi over 2. And 16 and 2 reduced to 8, so this is 8 pi feet for the arc length of this sector. Now to get the area, we have to use the formula 1/2 r squared theta. So in this case, that's 1/2 times 16 squared times our theta, which again is pi over 2. 16 squared is 256. We're essentially dividing that by 4 because we're dividing by 2 twice. 256 divided by 4, I believe, is 64, and we have a pi there. So 64 pi, and that's going to be square feet for the area.